Solving one-step equations. Look at the problems at the bottom of the page. You should have started seeing these in 6th grade. Does anybody recall seeing them in 6th grade a little bit? Okay. Let's refresh our memory here. In order to solve an equation, we must isolate the variable. If I was to isolate Taylor from the rest of the class, what am I doing? I'm putting her away. Does she have anybody else beside her? No. Isolate means to get alone. And we're going to keep each side of the equations balanced or equal. We can use inverse operation to move terms from one side of the equation to the other. Inverse operation can be thought of as the opposite or undoing operations. So inverse means the opposite. So looking at the inverse operations, what would be the inverse of addition be? Subtraction, because its opposite is subtraction. The inverse of subtraction would be addition. The inverse of multiplication would be division. And inverse of division would then be multiplication. Okay, over the year I have taught you many silly tricks, and my greatest known silly trick is how to solve equations, or my trick to solve equations. I made this up, so when you go to high school, I've had kids go to high school and say something about my silly trick, and the teachers look at them like they're... Yes, insane would be a good word. Yes. So, like I said, I made this up back when I was like at Molo, I think even. It's silly. So, I know most of you know how to solve these probably already. But use my silly trick first because we're going to be adding to these problems. So, number 1, as a 7th grader, I feel like you need to first draw your line through the equal sign. And I've created 2 different houses. Do you see a left and a right house? House over here, house over here. Then I see a married couple. Do you see them?
Yeah.
Who would you consider a married couple? 4 and X. Okay? They're sitting next to each other, holding hands, looking all cute. All right. Now, X wants the house to himself. He don't want to be married anymore. So, don't go home saying Miss Adams promotes divorce or anything. Again, it's my silly story of how I remember to solve problems. Okay? So, I have a married couple, a 4 and an X. X always wants to stay in the same house that it lives in. So it's living in house left. So who is getting kicked out the house? 4. What operation is going on between 4 and X right now? Multiplication. What is opposite of multiplication?
Division.
So 4 is getting kicked out by division. A fraction bar is the same sign as a division. So 4 is getting kicked out. He left. Who claimed this house?
X.
X claimed it. And then 16 divided by 4 is 4. Is X totally by himself?
Yes.
When the variable is totally by itself, you can use your answer to check. Plug it in for X. So plug in a 4. Is 4 times 4 16?
Yes.
So I should get 100% on solving equations test. Just by checking your answers. Okay? That's one chapter of my story. It's a big book. And when you get to Algebra 1, I had even more chapters. It was fun. I really did.
You need to write a book. This confuses me even more.
Does it really?
All
Alright. Shh. Shh. Alright. So let's look at number 2. First, create your 2 separate houses. And first thing your eyeballs should always be drawn to is the variable. So I find and I see X. I don't think X is married. Do you? No. So what I said, X has some kids. Alright? Guess what X is going to do? He's going to kick out his kids. It's time for him to leave. You 18, you out of here. So, right now, it's been adding 9. How do I get the kids to leave? Subtract 9, because X is staying in the house. Cancels out. Who claimed the house?
X.
X is like beast mode. He takes over everything. So then I have 13 minus 9. What is that? 4. So is X totally alone living the life?
Yes.
So I can test my number. 4 plus 9, does that equal 13?
Yes.
So I got it right. Okay, number 3. Draw my 2 houses. X got some what? Got some kids, but these kids got a negative attitude. You see their negative attitude? No wonder they getting kicked out. So how am I kicking out the negative 8? I'm adding 8. Maybe then they'll have a better attitude. X says, keep in the house. 14 plus 8 gives me 22. X is by itself, so I can test. Does 22 minus 8 equal 14? It does, so I'm good. Now here's chapter 3. It's where it starts getting good. Do you think X is married?
Yes. No. I don't think so.
Do you think X has kids?
No.
I think X is a girl.
He has a girlfriend.
Well, X has a creeper living in the basement. You see it? So, hey, I got to get moving. What is the creeper's name? 5. I'm recording, people. Blake. Okay. What operation is this bar right here?
Division.
Opposite of division. So the creeper leaves by multiplication. Why am I a big kid now and not using an X as a multiplication sign? Because it looks a lot like a variable. So 5 is getting kicked out. No more creepers. X is finally alone. He had no idea he had a creeper. 13 times 5.
It's a big number.
65. X is by itself, so I could test that. 65 divided by 5 would give me 13. Okay, I'm going to move on for time purposes. To the back. One-step equations can also include rational numbers. So number 7, married kids or creeper?
Married.
Married. So who's getting kicked out?
6.
How? Divide. 6 is getting kicked out by division. Division was the inverse operation. X keeps the house. Oh, 16 divided by 6. I will tell you is not perfect. It is 2.6 repeating. But is 2.6 repeating still a number?
Yep.
So it still can be an answer. What?
Will we have to do long division
Yep.
to figure that out?
Seriously?
Nope, you're not allowed a calculator. Hey, chill it. Now, number 9 is what you need to take away from me for next year and Algebra 1. So, most teachers have you doing the long fractiony way to solve this. I don't like the long fractiony way. It's pointless. So, you have a lot of problems you will have like this in 8th grade math and Algebra 1. Don't forget this. Does it look like married couple, kids, creeper? What do you think's going on? We don't really know. So what I suggest, always move your variable to the top and rewrite it. So 2x over 3 equals 8. Now we know what's happening with the story.
I think there's a creeper in the attic and in the basement.
No, bro.
They're married.
They're a married couple and they got a creeper.
Maybe it's like
Okay?
well, since my dad does dump
Maybe he's
trucks,
like cheating on her and then they keep stuck in the basement.
since my dad
Hey.
drives trucks, they have like they're all like bands from the radio. So my dad's nickname is actually Creeper.
Oh, really?
Yeah, that's pretty creepy.
All right.
Weird.
Stop, please. So, do you think X, of course X wants to be alone. Would he get rid of the creeper first or his partner? Creeper first.
Partner.
Creeper always goes first. So I'm going to multiply by 3 first. Creeper's got to go. Then I have the married couple. 8 times 3 is 24. Now the couple can break up. Who's getting kicked out?
2.
By what operation?
Division.
2's getting kicked out. And X equals 12. Okay, I can test this. Here's another trick. Whole number times top, so 12 times 2 would give you,
24.
divided by 3 would give you
8.
8. So I know I'm correct. Big type problem y'all should remember how to do unless you like doing a lot of extra work. Number 10, married, kids, or creeper?
Creeper.
So what operation do I need to do?
Division.
Multiplication. Who's leaving? Creeper with the name of 3.
Creeper.
So X then equals what?
X 21.
Negative 21. Is negative 21 a number? Yep, so it can be an answer.
Yeah.
All right. I'm moving to the bottom problems. But before I do that, I want you to glance at your homework problems. The ones at the bottom, that's word problems. There's 3 blanks, right? There's a blank that says variable, equation, and solution. Did I already have the expression equation talk? How do you know the difference between an expression and an equation?
Expression, they're all equal signs. Equation,
Equation has an equal sign. How do you think Miss Adams always remembered that?
Equal.
It looks like it's about to spell equal, and then it spells equation. So an equation has an equal sign. Expressions do not, right, Trenton? So there's 3 blanks on your homework. It says variable, equation, solution. So I'm going to solve these problems using these 3 blanks so you would know how it would work. It reads, if a chocolate cake is divided into 6 equal slices and each slice has 280 calories, how many calories are in the whole cake? So first, I have a blank of a variable. I've got to tell them what the variable stands for. Variables always stand for the unknown. Variables always stand for the unknown. Well, if I've got a question mark, don't I have something that's unknown in the problem?
Yep.
So your unknown's always coming from your question. 4 people are about to get written up, and I don't really care what 4 it is. Variables stand for an unknown. Questions are an unknown. So I need to rewrite the question somehow short. The question says how many calories are in the whole cake. So if I was to use a variable, what's a couple words I could rewrite that as? Words. What's another word for whole? Total calories in cake. That's my unknown. That's what I'm looking for. Now I can write my equation. I know equations always have equal signs, so I might as well just write my equal sign. So I know X has to be involved, and X stands for the whole cake. The first sentence says a chocolate cake is divided into 6 equal slices. How much of this cake is cut? How much of the cake is being cut? All of it. Don't I have a variable for all of it?
Yes.
X is the variable for all of it. Said it's being divided into how many pieces?
6.
So would you agree that the whole cake is being divided into 6 pieces?
Yes.
That's what this says. And each of those pieces have how many calories?
280.
280. There's my equation. So a solution, I would solve this, multiply both sides times x, and x would equal 1,680 calories. Because if you were paying attention, I explained I was going to do it like the homework, so when you did your homework, you weren't going to be confused. Okay, 14. Says, Pedro made a pot of coffee for some friends. He served 34 ounces to his friends, then measured that there were 20 ounces left over. How much did Pedro make? So I first need to define my variable. It's my unknown. Well, what's unknown based on our question?
How much did Pedro make?
How much coffee did Pedro make? How can I reword that simpler like I just did?
Total coffee made.
Beautiful. Total coffee made. Okay, equations, got to have an equal sign. Okay, so if I have a pot of coffee in my hand and I go to pour some out, What operation is that?
Subtraction.
Subtracting. So, what represents my whole pot of coffee before I pour anything out?
Total.
X, because an unknown, I don't know. X, I pour some out. What am I doing? Subtracting. How much am I taking off?
34.
I poured out 34 ounces. When I did that, how much was left? 20. So your solution, if I was to solve that, add 34 to both sides. There should have been 54 ounces, huh?
Yes.
If I solved that correctly.